I wonder if we might take a moment here to talk about some of the top things that could be mitochondrial insults that you cover in the book. So talk to us about smoking and air quality in our modern day and age and what we know that it does to the mitochondria specifically.
So let's start with the one that is definitely preventable, and that's smoking. So when you smoke, you generate toxin to the body, and one of the simple one to discuss is one that is also generated when you drink alcohol. It's called aldehyde. It's a small aldehyde that is you can measure in your saliva, and its level are really high, and it's toxic because it causes the mitochondrial protein to be oxidized and therefore not function properly. It causes damage to DNA, so it causes cancer and so on and so forth. So in this case, easy, don't smoke, okay? But pollution, you live in an area where air pollution is high. What can you do to fight it? So for sure, if you have recommendation not to go out and exercise during certain bad air quality day, then don't do that. It's really good advice. But so avoiding being present in that, or by campfire for a prolonged time, or barbecuing for hours. The person that barbecues oftentimes inhale a lot of the smoke from that. So trying to avoid it or watch wind direction and staying out of that. It feels unsatisfactory if I say that to a person that doesn't smoke and doesn't barbecue, if these things are still in the air. And this is one thing that we keep emphasizing. You don't need to be perfect in everything. So you can help your mitochondria through other things, and maybe your other examples will allow me to elaborate. But simply said is, there are quite a few ways by which, through small lifestyle changes, we can really improve our mitochondria and taking care of them properly.
Yeah, that's well said. I want to go back to the barbecuing. What you're really talking about is incredibly denatured proteins, right? And sugars. Is that like the charring, the charcoal, anytime you eat food that's super crispy and black?
And so yummy. Yes, it's charring. The charring is actually burnt fat. So fat can give aldehydes that is toxic. Charring could be the carbohydrate that are now reactively binding to proteins. This create what is called age.
Advanced glycation.
Yeah. End products.
Yeah.
End products.
Age is the whole example is always eat too many ages and it's going to accelerate aging.
That's right. So those are things that occur and give food this crispy taste. But also we have those occurring when you eat ultra-processed food, because to give crispiness to a lot of those ultra-processed food, they actually generate those aldehydes. And it's part of what the taste that we got used to. It's also a way to preserve the food in a bit. So all those are again things that we can avoid. It doesn't mean that you should never eat, I don't know, your favorite cookie or whatever it is that is giving you pleasure, because having pleasure, again, is also good for your mitochondria.
You know, it's interesting, a little personal anecdote. I've always noticed that I don't do well with fried foods from a young age. I would have fried foods and I would feel like I got like a sore throat, or I would have fried foods like French fries, or even some of the native foods that my mother would make from India that would be deep fried. And I'd always feel a little bit brain foggy. And I don't know if you've seen the modern sort of discourse that's out there, but some people are saying, okay, let's move away from seed oils and let's move towards beef tallow. Well, even if I have fried food, which is super rare, in beef tallow, but I consume a little bit too much, I always feel a little bit of like brain fog afterwards.
I don't know what beef tallow is.
Beef tallow, beef fat.
Ah.
Beef fat. Yeah.
So they recommend do that.
Yeah, some people are switching from seed oils to beef tallow. And I was making the commentary that any kind of deep fried food that I have, I always feel a little bit of brain fog. And I can't help but to think that there might be some sort of impact that these foods are having, maybe even more so for me, I don't know, genetic predisposition or something with my health, where I feel like these foods are, again, too much of them or frequency is impacting my mitochondria. Is there anything there?
Yeah, I don't know. But I can tell you that listening to your own body is a very good thing. So the fact that as a child you figure it out and started to avoid it is a very good thing. And I think many of us do not listen to our body. We feel that certain things are not good for us. I mean, I have colleagues who, on Monday morning come, I went out on Sunday, drank too much. I have such a terrible headache. I mean, come on. So it happens. You can do something about it and prevent it from the next one. I think that especially now when we are much more conscious about how and have great interest in changing our lifestyle in order to improve ourselves, we also during this process have to listen to our body. So it might not fit us all if we do one thing that somebody recommends that we do. So listening to our body is really
The personalization
important.
of health.
Exactly.
Yeah. A lot of young people have gotten the memo that smoking isn't great, but they've all switched over to vaping. Vaping.
Equally bad. I'm saying equally a bit in a rushed way because I didn't compare side by side. I have a colleague that is in the Department of Anesthesia that compared and says that they look very similar. They also generate aldehydes. They're also heating up things in your mouth, and so they have the same health or similar health risk to smoking, unfortunately. Yeah, and unfortunately, you see much more of vaping now than probably not as much as cigarette smoking in California, but still, I think that the switch over is more common in some other parts of the world. I think in the 50s, physicians recommend smoking.
Yeah.
Physicians in the 50s also said, don't exercise. It's bad for your body. When you were in the hospital, they kept you lying down, not moving for a long time. I think that we learn a great deal.
Yeah,
it's not their
learning.
fault. That's what they knew then.
Yeah, totally. Here's one that goes into your core area of researching in mitochondria and neurodegenerative diseases, and is also a little bit controversial as well. And that's the topic of pesticides, right? Pesticides are abundant in our culture, and even organic foods, sometimes they'll have organic-friendly pesticides that they'll have to use. What do you want people to know about pesticide exposure and mitochondrial health and how that's connected to our overall health and aging?
Man-made catastrophe. Pesticides are helping us because they increase the amount of food that is available for us. So it's really important, but it's also by itself is bad for us. What pesticides do is that they increase, again, aldehydic load, those reactive agents that are killing all our macromolecules or damaging our macromolecules. But there are some specific pesticides that work in, for example, in the mitochondria or particular target on complex 1. So
meaning that there's pesticides that have been designed to target the mitochondria. Is that what you're saying?
No, but they happen to act on the mitochondria.
Okay, so they weren't intended, but they are incredibly good, even if they weren't designed that way, at destroying the mitochondria.
The mitochondria. And complex 1, so in order to generate ATP, electrons have to pump proton out from complex 1. There is complex 2, 3, and 4, and then to complex 5, which is the ATP machine, the ATP generating rotor. Complex 1 is very sensitive to some of the pesticides. And in fact, there are now quite a few epidemiological studies that shows that people that have been exposed to pesticides early in their life or throughout their life are more prone to develop, for example, Parkinson's disease. And complex 1 dysfunction is known to be associated with Parkinson's disease. It's not the only cause because there are also genetic factors, but nevertheless, it's rather scary to see the correlation between being close to, working close to, or living close to where pesticides are used oftentimes.
Like a golf course.
Like a golf course.
There was that big observational study that was shared. I'm sure you saw it. It was all over the headlines.
Yeah, there was an article, I think yesterday in the New York Times, op-ed on that, or a column.
Yeah, that article actually was about a dear friend of mine's work, Dr. Ray Dorsey, and the work that he's doing to bring awareness to how his theory is that Parkinson's disease is a largely environmental.
Man-made, yeah.
But when you look at his book and all the different things that he talks about, that are the insults on the body, it's really perfectly matched with what you're talking about, because the underlying mechanism seems to be, amongst predisposition and other things, is that pesticides, air pollutions, things like dry cleaning chemicals that are out there, they are destroying our mitochondria and making it very difficult for our body to do the natural repair process. And that's increasing all these neurological disorders, including Parkinson's disease.
Listing pesticides and herbicides put another category on avoidable stress to your mitochondria. Avoidable maybe through policy change. So, for example, in Europe, many of those cannot be used, or through educating people that spray pesticides to protect themselves. Many people that are doing it are told to wear a mask or be covered, but it's hot. You do it every day. You kind of get tired of it. No, it's really bad, not only for you, but what you bring home, and also for you over time. But there's lots of interesting things about it that are inexplicable. So why pesticides are associated with Parkinson's disease, destruction of dopaminergic neurons, one subset of the dopaminergic neurons in one tiny area in the brain, and 1 centimeter away from it, there is another dopaminergic neuron cluster called ventral tegmental area that is associated with emotions and so on. And they are not destroyed. What's going on? I mean, there are so many things that we still don't know. Of course, I have theories about it.
I'd love to hear your theory.
Well, the dopaminergic neurons that first nucleus that is associated with Parkinson's disease may be much more active than the one in the VTA. That could be one explanation. The other one is how many assisting cells they have around them. So
assisting
cells.
Can you explain what that is?
So the brain is made of neurons and many, many more what are called collectively glia cells, and they are astrocytes and microglia that are were thought to be the glue of the neurons, but now we know that they are so important, so critical in how the brain is working. Just as an example, to create a memory, astrocytes have to munch on dendrites of the neurons to make sure that only certain connections are being maintained and others are not. So this is important normally. And then in neurodegenerative diseases, microglia are causing inflammation. They are kind of the immune cells in the brain and cause what is called neuroinflammation, which is of course bad. But they also transfer mitochondria to the neurons, take the bad mitochondria from the neurons. They transfer and metabolize neurotransmitters. I mean, these cells are really important. So it's possible that those cells in the two environment have better or less effective machinery to take care of it. I don't know, but we'll find out.
We know that the mitochondria are very sensitive to light. We'll chat about that in a second. What do we know about the mitochondria and their sensitivity to things like electromagnetic frequencies, Wi-Fi, all these electrical signals that are around us? What do we know about that?
Of course, I've read about it, but I feel like the information out there was insufficient for me to decide what's real and what's not. So,
do you think it's an area that warrants further study?
All areas warrant more studies. I think that it's very important that every statement that we are making is based on well-studied work behind it. So yes, and it's possible that there is something there that we completely forgot or never really paid attention to. I gave you quite a few examples of how we thought, it's good to smoke. We need to continue to carry out fundamental research and always try to think about how we translate it. And I feel like translation research, one way is to make drugs, which is something that I'm very interested in, and I've done a bit of that. And also translating information to the layman so that they know how we came to certain conclusion and whether there are things they can do about it. So yeah, always continue to study, continue to research, and it's so much fun. I mean, there are so many things that we still don't know, and I'm paid to be explorer every day. I mean, how much fun can that be?
Off topic, but I saw a talk yesterday by the head of Google's DeepMind, who won the Nobel Prize. I believe he won the Nobel Prize for a lot of their work in the space of AlphaFold. That was part of one of their projects that were there. Do you see AI being a part of the research of mitochondria? And are there things right now that are happening where people are using it, or you at your university are using it to help us understand or model out what's capable or what might be great or not great for mitochondria?
Okay, the short answer is possibly, maybe likely. One of the things that our minds can do and amount of information that we can handle relative to computers is not the same. And so connecting dots is part of the discovery process that maybe is possible when you can mine huge amount of data. And that's the first basis of AI. How did AlphaFold form? The computer looked at how non-protein structure looks like and started to create rules about how they fold and what kind of sequence that made the amino acid that makes a protein dictate what kind of secondary structure, which is there are two possible secondary structure, and how it folds to a tertiary structure and maybe quaternary structure when it interacts with other proteins, came up with rules. And then it can take a new one that we don't know its structure and create the structure for it. This ability for computer is easy because you take lots of pieces of information and you can be a good predictor of the next one and the next one through learning, through case studies. Looking at primary sequence and figure out what will be the secondary structure, I did it all my life. So I could do that. How it folds in 3 dimensions? No. I could see where will be corner in the proteins and turns, but I won't know how the whole thing will fold, AlphaFold scan. First of all, when we talk about mitochondria within the same cell, they're not the same. There are mitochondria that are dormant, there are mitochondria that do one business, and mitochondria that do another business. And then in other tissues, they are completely different. So our problem is that at the moment, what we've done is, with all the omic efforts, it's getting lists of things, characterizing things. Now, with this information, how they connect, if you learn one process, can you predict the next one and the next one? I think AI will be able to do very well.
Yeah, it'll be super interesting.
But not replacing humans.
Of course, in conjunction.
I think humans are very good in doing something the first time.
Yeah, the creativity, the insight, the breakthrough.
Yeah.
Okay, so we were going down a list. I've been enjoying this part here, by the way. I've been joining everything, but this part is really great because it helps our audience understand how these different insults are capable of impacting our mitochondria. And for those that care about brain health, that care about aging well, we understand that mitochondria are important, but we may not know all the different ways that they can be impacted. And in this case, we're talking about the 10 things that are out there. We've already worked through a bunch of them, and we have a few more, but the 10 things that are out there that are known to impact mitochondria for the worse. So I'm going to go through a few others to get your thoughts on it.
Sure.
Okay. So the next one that we have is radiation, UV and environmental. We obviously, most people know, especially if they've seen Chernobyl on HBO, that radiation is not good for the human body. But what are the ways that most of us living in our modern world would be bumping up against radiation, UV, these environmental toxins that are not good for mitochondria?
Radiation is actually one I feel comfortable talking about, especially UV and X-ray and the like. So radiation is a beam with high energy, and it can go through some moieties without changing them, and it can hit some moieties, proteins, lipids, DNA, and actually suddenly interact with them. So it's a question of chance. When we radiate cells, for example, in a dish, we can hit its DNA, and then suddenly you start to see uncontrollable growth or cancer in the dish. And we know the same thing happens to us when we are exposing ourselves to UV light in the sun, and our skin cells constantly screen for radiation. That's why our skin becomes darker with melatonin to prevent entry of the radiation deeper. But sometimes cells have been hit. on their DNA. And over time, usually it requires more than one hit, they will generate a tumor. And we see them on the skin. So that's one example of damage of radiation. But there are others. And I want to connect again with smoking through that. So you notice that people who tan a lot, especially European tends to tan a lot. You see that they have also many more wrinkles. Maybe now that with Botox and the like, we see that less. But it's very typical that you see a very tan person, and as you come closer, you see that they are really deeply wrinkled. The UV caused damage to the cells, and now they don't proliferate properly. They don't produce enough collagen, and so the cell wrinkle. But smokers, if you look at all smokers, you find that they have lots of wrinkles as well. And it's the same thing. It's this damage where the machinery that was supposed to clean it, and part of the machinery is the mitochondria, is overwhelmed. And so you see those damages. So those are two examples, radiation and smoking in this case, but radiation from UV and for other things. There is damage that is formed and we can correct it. I want to tell you one experiment that I did not do, but I instigated. I'm working on an enzyme. One of my projects, by the way, one of my postdocs said about me, I keep talking about the fact that I'm interdisciplinary, and she told me one day, no, you're just undisciplined. So guilty. I really, if I get excited about something, I try to study it as well. So I work on a family of enzyme called aldehyde dehydrogenase 2. Aldehyde dehydrogenase is an enzyme that gets rid of aldehyde inside our mitochondria. And it's best known for the fact that Asian, about 800 million people, have a mutation in this enzyme. So when they drink alcohol, they flush.
Right.
Thought to be totally benign. People said, oh, in fact, in East Asia, they say, oh, that means that my liver is strong, and that's why I flush. So it was thought to be a sign of health. And we didn't know any of that, but anyhow, we came across this enzyme being critical to protect the heart during heart attack. So we start to think, why is it important during heart attack when there is no oxygen? Why is it important? And we discovered that this enzyme is critical in removing aldehyde when there isn't enough oxygen, and so aldehydes are formed because there is more ROS. And this enzyme is very important for that. And then we read the literature, and nobody was interested in it. Nobody was thinking that aldehyde dehydrogenase 2 is important. In fact, it's good for your health. The head of a big lab at the NIH that studies alcohol, East Asian, said, I have this mutation and I'm healthy. So my colleague Chiang Chen and I went to Taiwan because we thought there 50% of the people have this mutation. Let's check. And we discovered endless amount of information that shows that this mutation is actually impacting your health. And how is it impacting your health? Because there is more aldehydes accumulating under a variety of conditions. So definitely alcohol. So if you drink alcohol or smoke or chew betel nut, which you might be familiar with, it's also common in India, it's increasing aldehyde in your mouth and in your gut, and you get cancer. Okay, so that by itself already was enough warning for us. But then we found that there is disproportionate higher percentage of people that have a stroke or heart disease or Parkinson's. Or, for example, we talked to a dermatologist that was trained in the US, and they told us that they were very surprised because they use laser to clear discoloration of the skin. And some of the women will come back because they will have lines from the laser. The laser created aldehydes, and if they don't get rid of the aldehydes, they get a brown line from the laser.
Is that typically women with like darker skin color, or it was happening to everybody?
I don't know. It was happening to a substantial number of people that this researcher said that they are going to genotype patients now to know whether it's correlated. But what I'm trying to say, that there were so many other diseases associated with this deficiency, and Jihyong Chen and I started an organization that we call STAR, because the mutation is called LDH2 STAR2. So trying to push the agenda of telling people, look, there is something you can act on. You have this deficiency, you are at higher risk. And in fact, he continues to do it and very effectively changed the policy in Taiwan. He spent a lot of time there, and now there is there is guidance for patients and for physicians about what other risks are associated with this deficiency. Now it was picked up in Japan and in Korea and in the US as well. What I'm trying to say with this story, these aldehydes accumulate under a variety of conditions. When Fukushima happened, I thought they should not send East Asians that have mutation in this enzyme to go inside and clean it up, because they are much more sensitive to that. And I tried to reach, I had colleagues there, I tried to reach people and I didn't succeed. Finally, I came back after several years. I went to Hiroshima, and University of Hiroshima, and I met a colleague there, and I was telling him again about how I care about that. And he said, you know what? I have an idea. I will do a study in which we check whether radiation from PET scan increases aldehydes in LDH2 deficient subjects. So those are healthy subjects that needs to go through this, check what happens to their mitochondria, and actually in this case also aldehydic load. So it's aldehydes that come from lipid. And he has now a small study that I think he just submitted for publication that shows that indeed there is a correlation. We'll see whether it will be published or not. But what I'm trying to say, all these high energy events
like radiation,
are generating aldehydes. And if your mitochondria are robust and they're not busy with other things, they can take care of it. But if there are genetic predisposition or you have other things going on, they just can't handle that. You have to do other functions all the time as well. So it's difficult to take care of all the insults that come in. So if we curb those, it's very important.
And it's partly what I'm hearing you say, that also if you are Asian descent, China, Japan, East Asian, right? That typically would be somebody who also has, the flushing effect, right? I think it's sometimes referred to as like a red glow.
Yeah,
right. Even by people of that community themselves. I've had friends say that. I don't know if it's derogatory or not. But
no, it's not.
That you should be even more paying attention to the topic of things that damage the mitochondria, like radiation. Is that partly what you're saying?
That's what I'm saying. When you can avoid it. But I also want to tell you something about that. It's not only East Asian. So for years, I would get email. I'm not East Asian, but look at me. Here is I am with before alcohol drink, before beer drinking, and here I am flashing constantly. And also, if you check on YouTube and the like, you'll find a lot of those little. So finally, after a few years of that, so always I would write, I'm not a physician. If you're flashing, maybe you should take care of it. And I always thought, this guy doesn't know his ancestry, or this woman doesn't know her ancestry. I decided after a while, okay, time to check it. So we have looked at the human genome sequences that have accumulated over the years, so full genome sequences, and ask whether there are any mutation in this enzyme in the human genome, non-East Asian. And sure enough, we found, I think, 6 different mutations. I mean, we found many more because most enzymes have changes. But we found 6 that are, two of them affecting 5% of Hispanic. I guess now they could add mixed American. I think that's what it's the right ancestry group to affiliate. There is one that is in South Asian. There is one that is in Finnish. People. So we isolated the gene. We generated the protein, and sure enough, the protein is less active. And it's less active or less stable or both. Not as severe as the one that is in East Asian. So these people were right.
There's people that are not East Asian that are still having that same flushing, which shows that their body's not great at dealing with the built-up levels of
one of their enzyme. We have 19 aldehyde dehydrogenase. One of the enzyme, very important one for environmental health, is not functioning optimally. Mm-hmm. Another way to say it is what I said earlier. Listen to your body.
Right. Pay attention.
Yeah, if you flash when you drink, or if you don't feel it when you drink, just don't. And I can tell you, I am one. I don't flash, but I'm Italian, half Italian. We always had a bottle of wine on the table, even as kids. My mom is from Tuscany. Never liked the things. And when I drink tiny bit, immediately I feel, off. Don't drink. Just listen to your body. There
Yeah.
are many other fun things to do.
I want to come back to radiation for a second.
Okay.
Right? Is there anything known in the literature through your work or somebody else's work that there are times in our life that you might go in for a CT scan? I turned 40 and I have a history of heart disease in my family and also being South Asian background. I actually think at Stanford University, they have the South Asian Center
Yes.
for Heart Disease.
Yeah, we
right?
have South Asian and we have East Asian.
Yeah. Because South Asians here in America have one of the highest, I think the highest risk of cardiovascular disease out of any ethnic minority. And so I wanted to see. And so I went for an advanced CCTA scan.
Mm-hmm.
I wanted to get a sense of like, where's my heart health and how is it? Knock on wood, it was excellent. My score came back as perfect as my cardiologist had seen for a male that was my age. And there are situations like that we might have to go in for, radiation, a scan, whatever it might be. Is there anything that we could be thinking about doing besides minimizing unnecessary tests? That's probably number one.
Right.
Making sure you don't get, certain tests too frequently unless they're medically necessary. Right. There's even a question about that with mammograms right now. It's a controversial thing, but the balancing act of, are there other tools that can look at breast cancer? And is the annual or mammogram of women above a certain age really the right approach? Or is there a better way to go about thinking about things? Again, everything is a cost-benefit analysis. But is there anything that we could be doing to protect our body during these moments that you know of? Besides doubling down on exercise, sleep, etc., are there things that could help us when we know we're about to endure a little bout of radiation?
You already answered it in a way. So first of all, it's those damages can be repaired. For damage to the DNA, we have a fantastic machinery that constantly works to correct damages to the DNA. In the mitochondria, there is also a machinery, not so effective, but we have quite a few copies of mitochondrial DNA. So if it's damaged, it will be removed. And so eventually it will be taken care of. So I would say that over time, much of this damage can be reduced. The question is the amount and what else is going on in your body. So oftentimes you take a patient for this treatment because something else is going on. And if you are stressed, or you're sick you have a virus at the same time, and so on, all these are bringing you higher to the brink where the damage is going to be too much for the mitochondria to handle. But I would say that in general, the reason why we have a recommendation dose and interval between treatment and all that is because physicians were aware of that and were weighing the benefit versus the risk in that. I would say, and again, I'm not a physician and not giving a recommendation, but just as a scientist, I would say that if you prepare yourself for something like that by, as you said, sleeping well, not being stressed, being well hydrated, eating proper food, rich in vitamins and so on, all these things will make your mitochondria overall in your body at a better state, so they can respond to that, and perhaps even mitochondria from areas that were not irradiated can help the ones that were.
On a personal level, are you worried about things like an annual mammogram? Do you seek out other solutions? Like these days, there's a popularity of certain blood-based tests that people do, like a Grails, looking at cancer in the earliest stages. How worried or not worried are you about that? And how much has that led you to seek or not seek out other solutions for things that are regular, exposure to radiation?
I am aware of the risk of radiation and I try to minimize it. So, I'm going to the dentist and oftentimes they say, oh, it's been a while. So I said, okay, but I take care of my teeth. So maybe we'll skip one more year, things like that.
A lot of people actually don't know that you can push back and you can say, hey, listen,
Exactly.
I understand. Is there a real cause for a reason that we need it? My teeth have generally been in good health. Not always. Some people don't have great teeth, but they've been good. is it absolutely necessary that we get X-rays right now?
Yeah, I think that considering it, and this discussion is good when you have a physician on the other side that is willing to listen to that. You can ask, if it been, you got X-ray several times and there was never actionable item coming from it, why do it, right? If it never really advised, you never saw a tiny cavity or a crack in your tooth and so on, things that we don't see, but the X-ray would. But it's not to avoid it. And I would say that physicians are very aware of that and sensitive, at least the ones that I've encountered never really push back if I said I didn't want to do something. Yeah. Regarding just a small comment that you made earlier, that for a 40-year-old, it was okay. So don't we all want to go through any kind of medical exam and say, oh, you're 20 when you're 70, or this is like, I never seen. So we always want to have this extra grade. But I think I really like that you said for a 40-year-old and you didn't kind of whinge or complain because you probably don't feel 40, right? I mean, I don't know how it feels one's age. We have expectations that are not realistic about ourselves and about our control over our health. But there are quite a lot of things that about our health that are in our control. They are boring, small things. But we should be active in them and then realize that there are times where our health is at a state where medical profession is the only group that can help us. What's really optimistic, why I'm optimistic about this time is that I think the more we know, the more likely we're going to be effective for you as an individual with our medical intervention.
Are you aware of this whole field called photobiomodulation?
You're coming back to that. Yes, and I mean, yes, I've heard about
Explain
it.
to our audience and give us your thoughts on it.
I have no explanation, and I'm not going to go into that. It's a topic. It's one of those topics where every time a topic was brought up to our attention as we were working on mitochondria, we try to look for the basic fundamental research on it and see if we are convinced or whether we see enough. And this is an example of something that I can say only in passing. Maybe 3 years ago, I looked into it because of a friend who brought it up to my attention, and I thought, maybe not.
Okay, got it.
But I don't want to dismiss it. And as I said, it's possible that now there are convincing data to say something like that.
Sure. So just so our audience is on the same page, we're talking about how light can impact our health, and in particular, how light can modulate mitochondria, for better, for worse. So the most basic version of that a lot of people have heard about, which I don't think you'd probably disagree with, is that, having too much of blue light or the wrong type of light at certain times of day has all sorts of downstream effects. The most obvious being that a lot of people are aware of right now from phones and indoor light is that it can impact our melatonin production. But it goes much deeper than that.
So this is one part that I'm very comfortable talking about, which is melatonin. So clearly, melatonin is a very important synchronizing of our clock, our biological clock, our daily clock. It's a very important agent, by the way, made in the mitochondria. So there is a connection directly between light and mitochondria.
Of course.
There are many. I have to say that. So we talked to Zeitzer, a researcher at Stanford who study sleep, about that, and he said, people who have a problem having regular sleep pattern, it's really good to be exposed early in the day to the sun during the early hours, and then during sunset, so it kind of helps set your sleep pattern, your sleep pattern to a certain rhythm that is normal. The light is critical in turning them on. Whether blue light from screen is an issue, when we asked him, he said, well, maybe right next to your face, but if you watch it on a television screen, above your fireplace, you're probably okay. In my own, for myself, I don't see any effect. I tend not to use my cell phone after certain hours or my computers. But if I do, which I did last night, for example, I fall asleep after that, no problem. So maybe it's personal and you have to pay attention to yourself and decide.
Yeah.
But sorry, I don't have the full science on that.
Oh, not at all. Not at all. There's a really great medical doctor who does a lot of really good breakdown about the science. I'll send you a couple of his videos. Very evidence-based, just talking. And again, he's very clear that this is emerging. So the conclusions aren't always there, but there can be a precautionary approach that people can take, especially in this day and age. We have so much of our time spent indoors. And in particular, he talks about all the benefits. We hear so much about UV and the sun being so damaging to the body and to the skin and aging the skin, which of course that's there. But we don't hear enough about the benefits of also certain wavelengths of light, including infrared light, and how we evolved as a species to get some of that.
Generating vitamin D so that your
Right.
bone will be strong and all correct. I mean, there are certain things that are not. I mean, the science behind them is really good. But there are also other things that I've encountered, so I kind of avoid talking about the
Yeah,
top.
totally. Well, let's hit on a couple more that are things that hurt the mitochondria, right? One of those, which is not always sexy to talk about, but it's something that a lot of people go through, is the idea of chronic stress. So how does chronic stress damage the mitochondria over the long haul? And as you've mentioned previously, this isn't about being perfect. So what are the top strategies that you found that are out there? Again, you're not a physician, but you've seen a lot of the literature that's out there. What can we do to help combat that?
Yeah, so chronic stress. Think about the fact that during stress, your body is on ultra alert and it's very busy generating ATP for certain purposes. So, for example, making sure that your muscles are acting and you're responding to any noise and any sort of stimulus from the outside. You're busy responding to the environment. You use all your energy, literally, your ATP, to focusing on that. So you don't do normal maintenance. And the mitochondria need constant maintenance. It's really essential that all the damage that occurs as a result of this nanomachine constantly working is that there are parts that get damaged through the extensive work. And there are machineries, there are mechanisms to fix them. But if you are constantly stressed and you put all your attention on the trying to respond to something that doesn't exist or maybe exists but it's not really a threat, you end up not taking care of you inside the body. You're not taking care of your mitochondria. So what to do with this? I mean, some of us are lucky enough that we can live life without survival, stress, and so on. There are quite a few people who don't. And yet there are even people under this condition can survive and take care of the stress by finding other ways to find release. So, for example, laughter, being with other people, enjoying something beautiful that you see. I mean, oftentimes you hear people talking about being in a battle and suddenly see a flower or something like that, getting distracted by the horrors that are around them and kind of finding themselves relax. People can take a walk outside, do puzzles or go dancing. So all sorts of simple things that you could do to improve your feeling. But there are also realities. I mean, there are parents that take care of terminally ill or very sick kids for other reasons, or spouses. That's extremely stressful. How can you avoid it? So here again, you need to make sure that you take care of yourself as well. So if you want to take care of a child like that or a spouse like that for a long time, the only way you can do it is if you can take care of yourself as well. You can't really just push on, because eventually you crack. Your health cracks. I think recognizing that stress, people say after that they are stressful, that they are exhausted. They're literally exhausted. They have used so much of their ATP for other things. Their mitochondria is not functioning well, and it's a cause of this prolonged stress. And then there are simple tricks to avoid stress. So, we wrote in the book that there was a period that we watched 3 hours of news at night. It was awful. And so, so now we still read the newspaper and we know what's going on, but we don't watch 3 hours of the news.
Yeah.
I mean, and especially since the 3 hours is a repetition, repetition. So it's, finding a way not to have an argument just before you go to sleep is another way to prevent stress. There is a small study that was done at UCSF by Lisa Apple, where she studied a mitochondrial dysfunction in women, and I don't remember exactly the overall study, but
there were caregivers, right?
That's a
Caretakers.
caregivers that they ask, what kind of mood did you have last night before the morning blood test? And they found that when women were describing last night being nice or happy or whatever, their mitochondria damage markers, which is pieces of DNA of the mitochondria in the blood, were lower. In these caregiver studies, there is another thing that they discovered apropos aging and stress, which is, about the telomere. Those
Right.
are the kind of the edges of chromosomes.
Yeah, what's the relationship between mitochondria and telomeres?
Crazy. So as telomeres shorten, they send something to mitochondria that damage them. As mitochondria are damaged, they send something that shorten the telomeres. There is continuous conversation between these two guys.
It's a downward spiral once they start the damage.
Exactly.
Is there an upward spiral as well too? That if the mitochondria are healthy, they're protecting the telomeres are protecting the mitochondria?
Healthy mitochondria are better for longer telomeres. If you ask whether length of telomere is reversible, there are studies that suggest that you can reverse in part the length of the telomeres.
Did you ever see that NASA twin study where they sent one astronaut is in space, one astronaut is here?
Well,
and
we have just one couple like that. That's the Kelly brothers. Yeah.
One of the surprising things about it was that the astronaut in space, his telomeres lengthened, if I remember correctly. And then he came back to Earth and they shortened. And everybody was a little bit, they were like, what was going on exactly?
I didn't remember that part, but what I remember that the mitochondria were not as good.
In space.
In space, yeah. There is studies that follow it of 50 astronauts that spent time in space. And when they came back, they looked at their mitochondrial function and it was reduced, but that was reversible. But, there is an issue of space and that we need to sort out before we send people to Mars, for example. That long-term
exposure to all the radiation and lack of gravity and everything.
We learned something from space when we talked to a person who's helping astronauts dealing with life in space regarding sleep pattern. We described that as well. So the problem was that initially they would go, around the world and they will have something like, I don't remember, 16 sunsets and sunrise or something like that. They couldn't sleep, and also it was freezing cold, and then they would wake up by hitting themselves because there is no gravity, so suddenly they will have wake up for that. So she did simple tricks. You think, how will solve this problem that they can't sleep properly? One of them is that they will let them sleep, so they will not wake them up. Let them sleep for 8 hours so that they will not, regardless of what was going on. And then they made sure that they are warm. I mean, one of the astronauts said that he put 2 computers on the feet of his sack so that to keep himself warm. So, and put screens on the windows. You don't need to see 16 sunrise and sunsets. Just put a screen on it. So simple things like that, and then tying them properly and so on. So we learned from space a bunch of things, not the least of which how we evolved with gravity, with 24 hours clock, sunrise and sunsets, and lots of things in our environment, and were beneficial for us over evolution. And so when we change it suddenly, we take some elements completely away. For example, being indoors all the time or flying to space. There is a cost to that, and we need to learn how to adapt.
Yeah, absolutely. For the person who's listening today, myself included, are there any ways or commercially available tests where I can get a sense of how my mitochondria are working today?
Wouldn't that be wonderful if we have a little ring or a patch that will tell us, because that will be very useful for us. That if we change our practice, is it really positive or negative on our mitochondria immediately? So right now, there aren't good tests, but I can tell you that there are quite a few groups that are working actively to see if they can develop such a test. The advantage would be really immense. We can look at a snapshot. So, for example, we can take biopsies, but nobody will agree to have biopsies of our muscles every, few minutes or hours or days. Even days it's painful. Or we can look at the telltale of damaged mitochondria, because when mitochondria are damaged, the cells throw them out, either degrade them in what is called rhizosome or release them to the environment. It's important that it releases to the environment of the cells. It's important that it releases to the environment of the cells because it says, I've been stressed. So the other cells know either to prepare for it or to help the cells that it's damaging. I mean, I'm using simple terms. But they also release to the blood. And so you can take a sample from the blood and see, for example, does it have mitochondria or mitochondrial DNA or mitochondrial fragments? And those tests are available. And the example of the women who take care of ill children, where that's exactly what they measure, mitochondrial DNA in the blood.
What's that test called? Like that they run in?
It's not, by the way, I don't think that it's a clinically proved, what is called CLIA test, but it's a test that you use that
in a research setting.
In a research center, and we do it as well. For example, we had a study on Huntington disease in which we generated an agent that inhibits neurodegeneration and prevents the death of the animals. It's called, or reduce the rate by which they died. It's called P110. And one of the things that we measured is mitochondrial DNA in the blood of the animal, and we showed indeed that mitochondrial DNA goes up in the disease and it goes down when we treat it. So this P110 agent is delivered systemically, benefiting the brain from a genetic disease that causes accumulation of proteins, not directly mitochondrial effect. And we fix it by treating mitochondria throughout the body with this agent. So tells us already quite a few things that were inexplicable for me when we discovered that in 2013. How can an agent that is in periphery can affect the brain? Almost the amount that we detected in the brain was really low. And why affecting mitochondria prevented or slowed down the damage from a genetic disease that is not associated with the mitochondria? And how does it work? So what it does is that it prevents mitochondria from breaking to two small fragments. So it reduces this oversplitting and then throwing out the fragments into the blood.
There's another story that you talk about inside of the book, which is a study of two women in their 70s.
Mm-hmm.
And I think that is a great story to tell here, to talk about the path that's available for us if we take care of our mitochondria or if we don't attend to it. Can you talk about that?
Sure. So those are imaginary women because we didn't interview the women that were participating in this trial, but we did talk to quite a few people who are conducting studies of that sort. So one woman, her sarcopenia, her muscles were not developed enough. She was weak and she had to sit down. The other woman was very active, and while she was waiting, she was stretching and moving around and so on. Those are examples of two women that both of them, to begin with, were not having health challenge, but one took an active action to maintain her own health, where the others was more passive. And I think that should give us lots of interest in trying to do the same. And in fact, there are quite a few clinical studies that showed, it's usually small studies, that showed the impact of exercising in old age versus young age. So even in old age, if you start a regimen of exercising, and again, since we are talking to people who are may want to take action, this you have to do. If you haven't exercised before, you have to get advice from your physician first. But once you start to exercise, and if you sample mitochondria for example, in the muscle, you can see a major improvement in their quality as you exercise. So you can reverse it. And we titled that little chapter, um, um, It's Never Too Late, but it's better not to wait. So you have even the 70-year-old woman may be put on an exercise regimen, and her mitochondrial function will improve. There is another study, by the way, from Belgium, in which they took cyclists. They cycled all their life, and then they took people who've never cycled extensively, and they compared their mitochondria in their skeletal muscle, in their leg muscle. And of course, the mitochondria of those that never cycled or were quite sedentary was poor, relatively to match aged those that cycled throughout their life. And then they put the non-cyclers through a regimen of exercise, I think for 3 or 4 months. And they caught up. They weren't as good as the one that exercised all their life, but they were dramatically better. So even if you are at your 70s and you've never exercised in your life and you start slowly, you can really benefit your mitochondria and therefore your whole body's health, your brain, everything.
Exercise is a great opportunity to get into the weeds a little bit more about everything that mitochondria are capable of doing. Break down some of the key mechanisms. If we were able to observe mitochondria during phases of cardio or resistance training or different types of exercise, what would we see about their capabilities in the human body?
Even if we can't see, unless we use all sorts of reagents that will measure how much ATP is made, how much reactive oxygen species are made, in other words, free radicals, how much building blocks are made, and so on. Unless we see all of this, we won't see much during exercise. But if you're asking what happens when we exercise in these mitochondria and how they influence the rest of the body, is that?
Yes.
Okay. So the first thing is clear, and that the one that people even in the 60s started to think about. When you exercise, your blood flow is increasing. That brings more oxygen to your heart, to your brain. Your lungs are expanding, and so on. That's clearly the case. But then when you look at the mitochondria, right away, you see a bunch of things that happen that are actually affecting your whole body. As the mitochondria are in the muscle are exercising, we find that the muscle release little treats. They could be treats from the muscle itself, so they're called myokines, or small peptides from the mitochondria themselves that are really benefiting the whole body. So, for example, the first peptide that is made in the mitochondria by the mitochondrial DNA that was described is called humanin. And the first person that discovered it is a Japanese researcher, and he thought it would be so important for Alzheimer's disease that it will bring back humanity to these people. Quite a few researchers are studying it, and one of them is Hasi Cohen here in LA, showed that humanins are released during exercise from the muscle. They benefit the brain. There are people who are over 100 years old, and they have a change in humanin, a different sequence in humanin, a different code in humanin that is correlating with their long life. And there are others that have greater likelihood to develop Alzheimer's disease, and they have a change that is correlating with that. So humanin that comes from our muscle when we exercise is affecting our brain, especially good humanin, like this Japanese centenarian, is particularly good. And there is one that is not so good. So what does it tell us? First, it tells the rest of us that we probably have the good humanin, the normal humanin, that exercising will be good for our brain. But it also tells us something about medicine, right? This is a small peptide. Could we use it to help patients that have non-functional or less functional humanin? So this is one example of quite a few little treats that the mitochondria generate. But I want to mention another one that most people think of as a negative. So when you exercise, the mitochondria are working faster, and there is always what we call leakage of electrons. So it's not a perfect machine, and about 2-5%, depending on mitochondria of the electrons leak. And when you have a free electron, it doesn't like to be alone. So then it binds to something else, and that generates, for example, reactive oxygen species. This generation of reactive oxygen species is not bad. It gives a signal to the nucleus, I need more mitochondria. I'm damaging the mitochondria right now through the exercise, so make sure that you synthesize some soon so that when next time I need to exercise, I'll have good mitochondria. And this small level of reactive oxygen species can also send signal to other cells in the body. So too much of that is not good, definitely not good. But having some is important. So this is another example of how the mitochondria in the muscle signal within the cell and outside the cell to prepare for the next round.
We've already talked about almost 7 to 10 things that hurt the mitochondria. And throughout the interview, you reminded us that exercise, including strength training,
right,
which is getting a lot of attention these days, especially when it comes to aging, perimenopause, menopause, fragility, avoiding muscle loss as we age, avoiding hip fractures. There's so much conversation about that, which is fantastic.
But also endurance.
Actually, do you want to touch on endurance and things like VO2 max and mitochondria and their relationship together? Is there anything you want to say on that topic?
Just regarding endurance, so oftentimes when people ask me about exercise, they ask which one is we should do, and we have kind of a rule when people ask which one, the answer is always both.
Both things.
But in this case, there is also very good research that shows that both are better than each of them alone.
Yeah.
So when you're building strength, you're working on increasing the mass of your muscle. Indirectly, if your muscle mass increases, there are also more mitochondria. When you're working on endurance, you exercised a lot, there was more ROS. Remember that when the ATP is consumed, when the mitochondria are working hard, they always leak some electrons that generate reactive oxygen species. And those are way to tell the nucleus, hey, I need more mitochondria here, make me more parts so that I can build more mitochondria. So endurance exercise does that and increases the amount of functional healthy mitochondria. It also increases a process that is called mitophagy, where damaged mitochondria are being eaten up, removed from a system. So they renew the mitochondria faster. So endurance gives you more of that. Strengths may give you more muscle, so you'll have more cells that will have more mitochondria in them.
And
so both of
feed
them
on
are
each
good.
Other.
Exactly.
Yeah.
So not either.
Yeah. No, it's good. It's good to understand the why, especially at the mitochondrial level, because then I find that when people get the reason why something is so important, they're more likely to stick with it.
I agree.
Like even especially like, let's say you have, one of the things we didn't talk about that damages the mitochondria is chronic sleep loss. And there are phases of people's life where you have a new baby, something might be going on, you're a caretaker, where you're just not sleeping well, right? I've gone through different periods of that. And it's amazing to know that, hey, even if you don't sleep well, if you can get some form of exercise that's in there, I'm literally imagining me exercising, helping to get rid of some of the damaged mitochondria that came from lack of sleep. Like I actually visualize that, and it makes me more likely to want to go to the gym or to do some sprints or to keep up with my normal routine.
Or not to eat garbage food.
Or not to eat garbage food. And the thing about that is that I always end up feeling better after I do that anyway.
In other words, again, you listen to your body.
Yeah.
Yeah. So you give perfect example. And this is one thing that we constantly emphasize, that it's not one thing that you could do to your body, and it's not one thing, or to help your mitochondria. It's not one thing that is a threat to the mitochondria. So you can mix and match. You can try to compensate. So, for example, if you have a crying baby and you wake up a lot at night, yes, so exercise can correct it. In fact, there is a study where they deprive people from sleeping, and some of them they allow to exercise and others they don't, and they saw that there is benefit to that. Now, I want to emphasize, it's not forever. You have to sleep.
Yeah.
Sleep is so important to our body. So important to our body. Now, there are people who are have chronic problems with sleeping. And again, when we talk to Zeitzer, he says that he thinks that a lot of people with problems sleeping is actually people who have a lot of stress, conceived or real, and not that lack of sleeping is. But anyhow, my point about that is that, okay, so you can beat yourself about the fact that you don't sleep enough or that you don't sleep well or it takes you time to fall asleep, and then you stress further. Or you can say, okay, I have to take it as is, and then I'm going to deal with it in another way. So I have to, eat properly and exercise or spend time in nature. Very good. Forest bathing. All these things have alternative. Laugh. So important. Spend time with friends. Do something that is pleasurable. Small things. I really think that you can look at the world as a scary place where things get worse and worse, and news are bad, and pollution and smoke, and or you can look at there are things in my control. Not everything is out of my control.
What do we know about any kind of key nutrients that are, in particular, really important for mitochondrial health?
Okay, let me start with one that I did not know
Please.
at all about. So we are all told all the time to eat lots of fiber, so we'll be regular.
Yeah.
And what we discovered when we talked to microbiome experts, that the reason why we need to have a lot of fibers is actually this is how we feed our microbiome. That the microbiome munch on these fibers, and as a result of that, they release a butyrate, which is the same thing as in butter, except we get very little from it when we eat just butter.
And these are these short-chain fatty acids?
Short-chain fatty acids, they go into the cells that line our colon, and these cells don't use glucose, but use butyrate to fuel themselves. And they produce then a thick mucus that provides another layer between the bacteria in the gut. Some of them are bad, some of them are good, preventing a barrier so that they won't get into the body. And when you don't eat enough fiber, the bacteria can munch on this mucus that you have, become thinner. And the study in mice show that they become thinner. And so maybe bacteria can come in and cause inflammation, and we know that inflammation is then bad for our health and so on. So that was the one that I was surprised. Regarding getting feeding the mitochondria properly, is of course providing them with these micronutrients and with minerals. So if you eat what we call balanced diet with lots of fresh vegetables and fruits, you get all these micronutrients properly. This is an example of something that to know if you don't is a simple blood test. A simple blood test will tell you, oh, I don't have enough vitamin B12 or B6. Those are very important for the functioning of the mitochondria, but also functioning of other enzymes. So having the right vitamins in our body through our nutrients is very important. And the question is, vitamin supplement or vitamins through our food? And again, research shows that when you consume it as part of your food, it's better because probably it's absorbed better. It's getting to the right place together with something else. So those are things that are these vitamins, micronutrients are very important for the normal functioning of mitochondria, and oftentimes we don't consume enough. So I think that's one thing that we can again take care of, being conscious of that and correct it through eating proper food, yummy food.
In addition to eating food, you also talk about the role of not eating food, fasting.
Sure.
What's the connection between fasting and mitochondrial health?
So here is a field that flourished for a while in a major way because there were studies starting with C. elegans, this 1 millimeter long nematodes that shows that if you starve them, they live longer. Starve them, you grow them in a dish on lots of bacteria, and if you reduce the amount of bacteria, they seems to be living longer. Instead of whatever 14 days, they live 30 days or whatever number of days. Then they've done these studies in other animals, importantly in mice and rats in the lab, and they live longer. So, okay, let's starve humans. We will live longer. The problem with that is that it takes many, many, many years and study of many people to see whether we actually live longer. So there is a challenge with the idea of starving. And importantly, and there are people who took it on, especially because of some health guru really suggesting that not eating is a good idea. The problem with that is multiple, not the least of which, if you don't eat or if you watch your calories in a very strict way, you end up not getting enough of these micronutrients that we were talking about. But also that the basis for starving animals was on the fact that those are animals that were living in the lab and getting food 24 hours. I mean, the mice and the rats in the lab have food and water 24 hours. And so they eat all the time. One of the critical things about eating all the time is that you lose the ability to switch. The mitochondrial metabolic switch is not working. And it's very important for mitochondria to work differently during the day and during the night. And a very big study that took 4 years to complete confirmed how important these other factors than just reducing the calories on the life of mice. So that study involved 960 mice. Huge number. They were divided into 5 groups. And they were giving the normal chow, normal diet, access all the time. One group was they took the food away for 2 days, or reduce the calories by 40%. And I don't remember now all the groups that they had. But what was unique about these mice was that they were not your typical mouse that you get in the lab or buy from services, so genetically identical mice. But actually, they collected mice throughout the world, wild mice. And then they divided the same family of mice into these 5 groups. What they found out is that indeed, mice that ate less live longer. But within a group of mice of genetically diverse background, it's always the same mice that died first. So genetic plays a great deal in whether you live long or not. But the other aspect that they found is that the mice that didn't eat enough and died, they usually died because they have immune problems. And these mice were still living in the lab, so they were not exposed to
pathogens,
to pathogen viruses and so on. There are studies in humans that show that people who are very thin and having suddenly have to be in a hospital, especially as they age, they fare less well than people that have a little bit of reserve. So, okay. So what about eating less? Definitely we consume too many calories. That's true. But one of the key things is that we consume calories all our waking hours, and perhaps that's not good. In fact, we believe that it's not good. So confining the number of hours that you eat to a lower number is important, not only perhaps because of the ability to switch your the mitochondria from using fatty acids to using glucose to using fatty acids at night, but also because it means that you consume less. Because if you sit in front of the television and you continue to munch, you just take more calories and probably of not good calories. So the one thing that we took from this actually a number of years ago before we wrote the book is that we try to not eat after dinner, and we eat dinner early. So we try to not eat 12 to 14 hours. I have to say that it's not always working. Maybe one more thing about diet.
Please.
Definitely not one food. I mean, there are craze, if you just eat, I don't know, cabbage soup for 10 days. One food is not giving you everything that you need, so it's not good. And also it's difficult to stick to it. And it's punishing unless you feel empowered by the fact that it's not good. So mixed food is very important. The other thing about if food and diet it's not suitable for everybody. So, for example, we say Mediterranean diet is very good, which is the Mediterranean diet is what we eat, but maybe not for people from Finland. So we have to consider what we grew up with, what is our genetic makeup, and so on. And if we make a switch, always listen to your body.
Good rules of thumb. Good rules of thumb. I want to go back to your core area of expertise and your passion for turning some of these insights in the research space into potentially drug development or things that are there. I mean, so many people have become aware of the potential role of peptides. You know, sometimes they're being used in a way that's a little bit off label, but there's a lot of emerging science where people are very excited about it. So what do you feel like the future holds for us in store when you're there observing how mitochondria can communicate with each other and send each other these little, to use your word, treats, these peptides to help with aging, to help with repair? What's possible for us as we move forward into the next few years and decades?
I think your question is touching my own motivation of working on this book with my husband, because I'm so optimistic about the future of medicine as a result of the knowledge that we acquire now about how mitochondria work, what happens when they don't work properly, and how we can help mitochondria help each other. So I think medicine it's exciting period where we'll see more medicine, I expect. The medical field more focusing on improving mitochondrial health, and through that addressing chronic diseases. Regarding peptides, so yeah, the reagent that I used initially were short peptides. Not, there are chemical entities that are like aspirin, they're global, and the peptides are tiny pieces of proteins. I didn't work with natural pieces of proteins. I've picked up a piece from a protein that I was working on and realized that it can do something different from the whole protein. But mitochondria generate pieces of proteins that were in evolution refined so that they will do the magic that they do. So it's possible, for example, that we talked about humanin in the beginning of the conversation. It's possible that humanin or other peptides like that can be given to complement what your mitochondria were supposed to provide for patients that generates them less well. So amazing. It's possible that you can find ways to enhance the ability of the mitochondria to deal with aldehydes. It's possible that you could improve the mitochondria sensitivity to switching from using glucose to using fat and so on. But I think the biggest thing in my mind is the discovery that the mitochondria are not homebodies. So they move in within the cells from the nucleus to the periphery. So for example, if you have a wound in your skin, the cells that needs to close the wound push all the mitochondria to the front of the cell. It's like in the army, the supplies are sent to the front to help the soldiers. Mitochondria are doing that. If you're thinking about in a disease state like stroke and so on, researchers found that cells surrounding the area that was infarcted can send mitochondria to the area that was damaged to complement for the damaged mitochondria. So mitochondria can move locally. They can also move a larger distances. So now there is a whole industry, new biotech companies that are still working on the ability to actually deliver mitochondria by injecting them and helping the whole body. The first experiments were done at Harvard, I believe, where they purified mitochondria from one part of the body of a little girl, one muscle, and then injected it to the heart to improve the heart, and it was working. And so they repeated it now, I think, 16 times. And it seems like it's improving the heart. There are lots of questions of whether this transplantation of mitochondria is really, the mechanism is really understood, but the data are really good. And so there are now companies that are purify mitochondria and find ways to store them so that they can deliver them when needed. So maybe in the future you can go for mitochondria treatment and, rejuvenate your pool of mitochondria.
It's like something out of Star Trek.
It sounds like, but I don't think it's so far because there are now active clinical trials, multiple clinical trials in this field. We have to wait and see. There is a lot. Some people say it's not possible for the mitochondria to live outside the cell. But then you look at the data, and definitely there is benefit in animal models, no doubt, and also in humans. So we'll see. I'm excited about it. There is a huge prospect of focusing on mitochondria as a way to deal with whatever chronic disease occurring. And that's not to say that it's always a fault of the mitochondria. It just means that it was tasked with so much work that by boosting it, you boost the health.
Yeah, that's such an important message. As we wind down here and the audience is taking in all the beautiful knowledge, and the book is fantastic, by the way. In fact, we have a copy over here. If we could just hold it up to the camera, The Life Machines, How Taking Care of Your Mitochondria Can Transform Your Health. And we have a link in the show notes, so anybody can go purchase it. I highly recommend picking up a copy. What is the lasting thought that you want to leave our audience about the power that their own body and their mitochondria has?
I think that our modern life are fraught with a sense of lack of control, that things happening to us, stresses and so on. And I think that one thing that when you think about your own mitochondria is that we gave you tool to feel like you can collect or knowledge to collect or to gain some control of what's going on with you. So control can be regained to a limit. Of course, your genetic makeup and so on is going to remain an issue. But my hope with the book is that we gave some tools to deal with a sense of lack of control, and also to be patient with what's going on right now in development and kind of drugs that we will have just around the corner. I really believe that this is exciting times, that human health will be taken care of better.
You know, one of the things that I was chatting about with your husband about is that it's so great in this day and age that there's things like podcasts, because the audience and the community, one of their favorite things is to hear directly from the researchers that are actually doing the work. So obviously we have this podcast, we have your book, which again, I hope everybody picks up a copy of. Are there other ways that people can keep in touch with your research? Are you active on social media? Do you have a TikTok yet or Instagram?
I am not active on social media.
Any chance of making that happen?
Probably not, because I'm really busy with
You're
other
busy,
things.
for sure.
But people can look me up at Stanford, and we provide a website for my husband's and so on. So, yeah.
Well, this has been fantastic, and I'm so glad that your publishers and PR team reached out to us, because I think that this topic is an important one that deserves a lot of attention.
I really appreciate taking so much time with me, Dhru. Thank you. It was fun.
Absolutely.
Thank you.
Thank you. YouTube, if you enjoyed what you just saw, keep watching for more great content on how to improve your brain and your life.
This man went on to lose 160 pounds now and has kept it off to this day. But he was able to do things he hadn't been able to do since the time of his diagnosis.